In 1996, a committee of leading astronomers led by Alan Dressler formally recommended that NASA develop a space telescope capable of observing the heavens in infrared light, the wavelength enabling astronomers to see through dust and gas clouds, expanding humanity's view of the universe. The proposed telescope would have a diameter of more than 4 meters and operate in an orbit beyond the Moon. Its powerful capabilities would enable astronomers to peer even deeper into space and understand things that happen further back in time, pivoting us with a much more comprehensive understanding of the universe as we know it today. And well, let's just capture the clearest image seen in history. Join us in this video as we take a closer look at what the James Webb Telescope has been up to and how it could change everything. But before we get into that, let's reel it back to the James Webb Telescope itself, the James Webb Telescope, and how it all began. After the initial recommendation for the telescope in 1996, 3 teams of scientists and engineers from both public and private sectors met to assess NASA's feasibility in building the proposed telescope. All 3 teams concluded that the telescope could be built, and in 1997, NASA agreed to fund additional studies to further refine its technical and financial requirements. By 2002, the agency had selected teams to build the key instruments for the telescope, as well as an advisory group of astronomers to provide guidance for its construction. That same year, the telescope was officially named the James Webb Space Telescope in honor of NASA's former administrator, who made significant contributions to the development of the Apollo program. As construction on the Webb telescope began in 2004, engineers and astronomers were faced with the challenge of creating new technologies and processes to meet the demanding scientific requirements of the mission. Unlike Hubble, which could be repaired and upgraded by astronauts working from Earth, Webb would have to operate at an unserviceable distance while still meeting its many demands. Despite these challenges, the team successfully completed all 18 mirror segments and conducted rigorous testing to ensure that they met the required specifications. Things were officially at the point where you could actually picture the telescope getting into space successfully and getting the work it needed to be done. The construction for the James Webb Space Telescope as a whole began in 2012 and continued through 2013, with individual pieces of the telescope being constructed at a variety of locations across the globe. In 2013, construction began on Webb's sunshield layers, which protect the telescope from excess heat and allow it to function effectively in space. Over the next several years, Webb's various scientific instruments were subjected to rigorous tests of extreme temperature and vibration, and its 18 individual mirrors were carefully installed onto the telescope's backplane structure. In 2017, all of these components were integrated together and tested at NASA's Johnson Space Center in Houston, Texas. In addition to being able to withstand the effects of Hurricane Harvey without any problems, the telescope and its instruments also completed a final round of environmental testing in a giant thermal vacuum chamber to ensure their proper functioning once deployed in space. Finally, on December 25th, 2021 at 7:20 a.m. EST, Webb was launched into orbit around the Earth. So, how exactly does the telescope work? The thing about space exploration is that things are often oversimplified, so it sometimes doesn't make much sense when you first hear about this telescope. It might sound like yet another telescope, but it's not. It's extremely unique. That's why it took decades for it to go from conception to actually making it to launch day in the first place. The James Webb Telescope is a powerful infrared telescope designed to observe celestial objects that are too cool or faint to be observed using traditional telescopes. These objects include stars, nebulae, and planets in the early stages of their development. Since these celestial bodies emit most of their heat as infrared radiation, the researchers made sure that this telescope is optimized for capturing this type of radiation and allowing us to better understand these distant objects. Infrared radiation is unable to pass through gas and dust, making it appear opaque to the human eye. However, the Hubble telescope is able to see visible light and infrared radiation, as well as ultraviolet radiation, allowing it to image objects obscured by gas and dust, giving us a clearer picture of distant phenomena in the cosmos. Additionally, infrared radiation can be used as a tool for studying the properties of materials on Earth, such as their chemical composition and temperature. Thus, infrared radiation has many important applications in astronomy, science, and technology. It can help us to better understand the structure and evolution of stars, galaxies, and other astronomical objects, or it can be used to detect signs of chemical pollution in our environment. To achieve this goal, the telescope is equipped with a large mirror array, advanced imaging and spectroscopy equipment, and state-of-the-art thermal control systems that allow it to operate in extreme conditions, which, as you know, space is. This telescope is supposed to wander the open space all on its own, so it needed to be designed in a way where it could tackle anything out there. No help necessary. After the telescope is launched into space and separated from its launch vehicle, it unfolds and begins to journey to its destination, executing a complex deployment sequence along the way. This process involved a number of important steps, including crossing the moon and separating into different pieces. Once fully deployed, the telescope began operating as one of the most advanced instruments of its kind. So, how did the James Webb Telescope make it to space? Before we get into the discoveries this revolutionary telescope has made, let's take a look at the process it had to go through to make it into space. The first thing was, of course, the launch that the scope underwent. The solar array deployment. Then, on day 3 of the mission, still inside the spacecraft, 2 special pallets will be deployed. These pallets will hold Webb's essential sun shields, which are designed to keep the telescope cool and allow it to function properly in space. The deployment of these shields will play a critical role in ensuring that the telescope can operate effectively throughout its mission. On day 4, the tower holding the instrument package was lifted to its final location and assembled. This process involved a series of complex steps, but because of the way the telescope is built, it went seamlessly. After that, we have the momentum flap deployment, where the sun's solar pressure acts on the large sun shield, creating force that stabilizes the telescope. After that was the sunshine membrane cover release, which releases special covers to expose the tennis court-sized sun shields. Once all that's done, we had the membrane tensioning, where the sun shield and mid-booms are deployed, and the sun shield is tensioned to separate its 5 layers. But it doesn't really end here. The James Webb Telescope had to undergo several major steps as it was deployed in space. On day 10, the secondary mirror was deployed along with a support structure to hold the smaller mirror in place. Then on day 13, the primary mirror wings were extended, giving the telescope its full size and shape. Once these steps had been completed, the telescope was ready to begin its mission of observing distant stars and planets. What is the real purpose of the James Webb Telescope? One of the most intriguing things about the James Webb Telescope is that it wasn't really built to do one thing. It's supposed to get to the bottom of a lot of stuff. So let's dig a little deeper here. Going back in time, telescopes like the James Webb Space Telescope allow scientists, like Daniel Einstein, who's an astrophysicist at the Harvard-Smithsonian Center for Astrophysics, to time travel back in time and observe galaxies as they were in their earlier stages of formation. Because you see, light takes time to travel. The farther away a galaxy is, the older it appears. With its unprecedented ability to observe distant galaxies, the telescope can examine the early evolution of galaxies to better understand their formation and evolution. By analyzing different galaxies at various stages of development, scientists like Einstein can piece together a comprehensive picture of galaxy formation and evolution over time. Webb's infrared capabilities make it perfectly suited for observing distant galaxies. Due to the expansion of the universe, light from these galaxies is stretched out over time, shifting its wavelength from visible or ultraviolet to infrared. With its large and cold design, Webb excels at detecting infrared signals, allowing it to see much deeper into space than other telescopes. This gives it a unique ability to observe galaxies as they are growing and developing, capturing snapshots of their evolution over time. Thanks to Webb, we can gain new insights into the formation and growth of galaxies, furthering our understanding of the universe as a whole. Study stars from the literal point of their birth. Stars form from dense clouds of gas and dust known as stellar nurseries. These clouds are so dense that visible light is unable to penetrate them, making it difficult for scientists to observe these regions using conventional telescopes. However, infrared light can pass through the dusty clouds more easily than visible light can, giving scientists a unique view into the heart of these stellar nurseries. The infrared capabilities of the Webb telescope will enable scientists to study these regions in much greater depth than was previously possible. Marcia Recca, an infrared astronomer at the University of Arizona and principal investigator of one of Webb's cameras, explains that this is because red light can pass through the dust in our atmosphere better than the shorter wavelengths like blue light. In addition, infrared light can penetrate even deeper into dusty galaxies than visible light. For example, when we look at a setting sun, it appears redder than it does in the daytime due to this phenomenon. With its enhanced infrared capabilities, Hubble's been able to study stellar formation only on a superficial level. In contrast, Webb's broader range of infrared wavelengths will enable scientists to peer deeper into the dust and gain a more comprehensive understanding of how stars are born and develop. Give us insight into black holes. Black holes are some of the most mysterious phenomena in the universe, as they are literally invisible to us due to their ability to trap light. However, we can observe the effects that black holes have on other stars and galaxies surrounding them. Using telescopes such as X-ray telescopes, scientists have been able to study different aspects of black hole physics, such as the extremely hot and energetic environment near black holes caused by the violent shredding of nearby stars. With the launch of NASA's Webb telescope, scientists will be able to study black holes in greater detail using its infrared instruments. By observing the cooler gases and stars that swirl around black holes, they can better understand these mysterious objects and the complex physics that occurs near them. So, despite their seeming invisibility, black holes are still an active area of study for scientists and will continue to be an important focus of research in the future. The stars that are found in the dense, dusty regions of space can be difficult to observe due to the obscuring effects of the dust. However, with its powerful infrared capabilities, the Webb telescope will be able to peer through this dusty curtain and provide scientists with valuable data about these stellar environments. By studying the temperatures, speeds, and chemical compositions of these star-forming regions, researchers can learn more about their mass and size, as well as how they feed on stars. By gathering this data, we can gain a better understanding of the fundamental processes that drive the growth and evolution of galaxies throughout the universe. Ultimately, this information will help us to better understand how stars like our own sun formed and evolved over time, questions that we never really thought we could have the answers to. figure out if there's life on other planets. Using infrared wavelengths, the James Webb Telescope can detect the chemical signatures of life in the atmosphere of exoplanets. These signs may include carbon dioxide and oxygen released by biological processes such as photosynthesis, as well as other chemicals associated with habitability. By analyzing these chemicals, scientists can look for evidence of life on other planets and assess their potential habitability. In particular, Webb can detect the chemical signatures of key biological molecules, such as water and methane, which may indicate the presence of life on other planets. Additionally, Webb's highly sensitive instruments will enable scientists to study atmospheric conditions on these exoplanets in greater detail than ever before. Overall, this powerful new telescope is poised to revolutionize our understanding of the universe and could even help us find evidence of life beyond our planet. Webb is a powerful space telescope that is equipped with two instruments that will allow scientists to analyze the wavelengths of infrared signals from planets beyond our own solar system. This information can be used to determine the chemical composition of an exoplanet's atmosphere, allowing scientists to study alien worlds in great detail. The field of exoplanet science is still relatively new, having been first pioneered in 1992 with the discovery of the first exoplanet. Since then, scientists have discovered thousands of planets in our universe, many of which exhibit unusual characteristics that are not found on Earth. Although humanity has only recently discovered the existence of exoplanets, our knowledge of these distant worlds is still relatively limited due to current technology. It is difficult for scientists to gather detailed information about these planets using infrared spectroscopy. However, with new space-based telescopes like NASA's James Webb Space Telescope, we will have a much clearer view of these exoplanets and be able to learn more about their properties and characteristics. Unlike Earth-based observations, which are hindered by the limitations of our atmosphere, Webb is designed to operate in space, where it can observe infrared light without interference from Earth's atmosphere or surface radiation. All of the things we've just talked about seem a little too good to be true, but that's not actually the case. The James Webb Telescope has already made waves in the world of science and discovery, so let's take a closer look at some of the most groundbreaking ones. First up, getting some real exoplanet information. The JWST was designed with the goal of finding planets orbiting stars other than our own Sun. Preliminary observations have shown that this capability is working well, as the JWST has been able to detect light directly from exoplanets using several different methods. One example is its ability to image Jupiter-class planets like AHIP 65426 using the transit technique, which involves observing the planet as it passes in front of its host star and blocks some of its light. In addition to this method, JWST observations have also found evidence of water and carbon dioxide in the atmospheres of two Jupiter-sized exoplanets through the transit method. These observations indicate that JWST is functioning better than expected, allowing for more detailed and sensitive studies of exoplanets. Overall, these findings suggest that JWST not only has the potential to study planets beyond our solar system, but can bring us a staggering amount of information that we could have only hoped for in the past. Then we've got faraway galaxies. As astronomers observe objects in the universe that are farther away from us, they are able to see light that has been shifted toward longer wavelengths. This phenomenon is known as the Doppler effect, and it occurs because of the expansion of the universe. To take advantage of this effect, NASA designed the James Webb Space Telescope, JWST, which can detect the earliest galaxies in the universe that formed just a few 100 million years after the Big Bang. Initial observations with JWST have already revealed many candidate galaxies at these early times. proving that astronomers may now be able to study the very earliest moments of cosmic history using this telescope, along with other pieces of revolutionary technology chiming in. On top of this, we might be getting answers to questions that were long thought way too complicated to even approach. Finally, the one you've all been waiting for: the clearest image in history. In the beginning of this video, we talked about how the James Webb Telescope just captured the clearest image in history. And well, now that you know about the inner workings of the telescope itself, let's talk about the image that's making the world of science spin. NASA's James Webb Space Telescope has just captured the clearest view yet of Neptune's rings, which have not been seen in detail since NASA's Voyager 2 spacecraft imaged them more than 30 years ago. In addition to revealing the bright, narrow ring surrounding the ice giant planet, Webb's cameras revealed that these rings are composed of millions of tiny, dust-sized particles that scatter light in unique ways. Neptune's high-resolution image also provides new insights into the complex weather patterns on Neptune, including long-reaching cloud bands and turbulent storms. Scientists are still studying these features to better understand the planet's dynamic atmosphere. In addition to being an incredible scientific tool for observing the universe, Webb is also a powerful tool for studying our own planet. By studying the atmospheres and weather patterns of distant planets like Neptune, scientists can learn more about how weather works here on Earth. With its impressive resolution and sensitivity, Webb promises to revolutionize our understanding of planetary systems throughout the galaxy and beyond. We can't wait to see what discoveries it will uncover in the years to come. And on that note, we'll wrap up this video. Do you think the James Webb Telescope is capable of going beyond the level it already has? Let us know in the comments below. If you like this video, please give it a thumbs up, and we'll see you in the next one.